Hi, hello everyone. This is Shao from Taiwan, and it is my honor to be sharing with you the application of smart planning and design technologies in Taiwan road engineering. Here's my agenda. The presentation today will be divided into three sections. First, planning stage. I'll talk about the big data applications in traffic characteristic analysis. And then, design stage. First, I'll share with you the LiDAR and UAV survey data with Revit BIM model. And then, the roadway and land development design with Civil 3D software. Lastly is my conclusion. First, big data analysis. In Freeway Number 1 widening project, we use telecom data and freeway vehicle data to do the big data analysis, and further we visualize it in Google Map form. We use telecom data to identify the traffic hotspot and congestion time on local roads. So we can show the video on the left-hand side. We can see the red spot here. It indicates that there's construction here happening. So since the video is being analysis throughout the day, so we have the time here on the top of the video. Further, with our freeway vehicle data, we can do the similar thing to find the construction on the freeway. So we see the video on the right-hand side. So we can see the construction happens near the city first. It's around 8 a.m. in the morning now. And then it became purple. It means it is more jamming now. So after 9 a.m. in the morning, we discovered that the construction going north to this area here. And the construction only ends around noon. So it is our target area. So after we identify the target area, the target construction location on the freeway, we zoom into that specific area. So we collect the vehicle data from 2014 to 2020, and we sort it into weekday, weekend, and holiday. The southbound lane is on the left side of the table here, and the northbound is at the right-hand side of the table here. So we noticed that the construction happens on weekend in the afternoon. However, the construction on weekend was improved from 2017 after the approval of using the hard shoulder. But then we found out that during holiday, there is still construction happening here. So we try to understand why, and we'll have a closer look at it. We discovered that on the northbound lanes from Tongluo to Toufeng, the construction happens at two specific locations. First one is before Toufeng entrance, here. And the second one is before the way station area. And there are both construction happening in the afternoon. And the speed dropped down to only 20 to 40 kilometers per hour. It is quite slow on freeway. First, let us look at the area before Toufeng entrance. We discovered that the congestion starts near the end of using the hard shoulder. We then realized that the cause of the congestion here is because the traffic on the hard shoulder interwave with mainline traffic that is going to the Toufeng axis. The interwave makes the traffic slow down and cause the congestion, as shown in the graph here. Then, let us look at the way station area. We found that the congestion starts at 122K and ends at 118K. Then we look at the horizontal around this area. We discovered that there are multiple reverse curves with small curves radius. And vertically, it is also quite undulated in that specific location. As a result, the traffic will definitely slow down in this location and cause the congestion over here. After we identify where the construction are and the cost of it, we give the corresponding improvement proposal. For Toufen, we propose to extend the northbound decelerate lane, and for the way station, we propose to extend the northbound accelerate lane. It can not only give more traffic capacity, but also solve the specific congestion problems. Then, secondly, I would like to share with you is what we did with LiDAR and UAV survey data, along with our Revit BIM model. We start by control survey, and then we move on to topo LiDAR survey, as shown in the picture here. Here is the survey situations. And then we do some coordinate corrections. And the most important thing is the point cloud modifications. Before the modifications, the point clouds are not overlapping with each other. After the modification shown here, you can see the two towers is overlapping correctly with each other. So here is our final LiDAR point cloud result. You can see clearly the existing bridge and the railway beneath it here. All the details here, and even the electric wires of the railway here. This project is the retrofit of the existing bridge, so our design engineers finish the calculations and do the Revit BIM models in Revit. So you can see the capping here, the capping reinforcement here, and also the foundation enlargement here. The model is then combined with the point cloud data, as shown in the picture here. So you can see the point cloud here and also our Revit model. We use this combined model to check the foundation encroachment from the railway, as you can see from the top view here. And also we can review it in 3D. We do the construction analysis based on the model too. We put the construction machines there and do the horizontal clearance check. Also, we do vertical clearance check beneath the electric wires. The clearance is more than enough. Moreover, since we noticed that there are transmission wires on top of our construction path, so we use the point cloud model to check this vertical clearance as well. So the outcome is the clearance is 5.2 meters high. So our construction path is okay. The third topic I would like to share with you is how we do our roadway and land development design with Civil 3D software. Here is the modeling structure in Civil 3D. First, we will have our survey data, and then we will generate the original DTM. If it is the land development project, we will have the urban planning layout, and we can set out our horizontal alignment based on the planning layout. With both this, then we can generate the alignment profile, and then we will generate the sub-assembly, and then we will generate the assembly according to our typical sections. With all this, we can generate our alignment 3D corridor. And moving on, we can have row intersection component and finish the row surface. For pipeline wise, after we have the alignment, horizontal alignment, the pipeline will develop its own horizontal alignment as well, and its own vertical profile as well. And combined with the roadway corridors and the pipeline networks, we can generate the combined models. So here is an example in our A21 project in Taoyuan City. When we have the original survey data, we establish the original DTM with this survey data. So as you can see, this is the generated DTM in Civil 3D. And then we establish the horizontal alignment as shown here. And then we do the vertical profiles. And when we do the typical sections, which is called assembly in Civil 3D, and combine these three, we can generate the corridor here. in Civil 3D. Since it is a land development project, so we combine all the roadway corridors, all the road here, and we combine them together, and then we can have our finished surface DTM. For pipeline wise, we also established the pipeline models. Here you can see the common duct pipe network and also the drainage and sewage network. And most important is that we also build up our pipeline manholes accordingly. So you can see all the manholes in common duct system and also in drainage and sewage system. For the pipeline vertical profiles, we can combine it along with our roadway alignment. So we can see in the profile view here, there are some manholes misput here in the yellow circle. So we can adjust it just on the profile view. So we drag it down to the correct location to do the adjustment. So here is our finished overall pipeline networks. So we combine the common ducts, the drainage and sewage system all together. And then we combine our roadway corridor and also the pipeline corridor into one BIM model. Furthermore, we can also do the conflict detection. So here's an example. The sewage manhole is conflict with drainage box cover. So we can thus adjust the sewage system here. Here is another example. So it is Xinzhuang project in New Taipei City. We also generate the original DTM using the topo survey data, and throughout the triangular method, we can show it in the elevation analysis wise. So in a darker place, it means lower parts, and the brighter one is the higher ground. So we also generate all our roadway corridors here. It is the combined corridors. So you can see we do the roadway intersection component, all of the corridor components here. Also, for the pipeline wise, we also have our overall pipeline networks. So the blue one is the drainage system, and the brown one is the sewage system, and so on. And we also reference the 2D drawing here, so you can see the corresponding parts. We can also do the conflict detection here. So you can see the blue one is the drainage system, and the green one is the common duct, and it is the electricity common ducts. And the yellow one is the common duct of the telecom systems, and the orange one is the sewage system. So this is after our modification with the detections. Lastly, the conclusion. Taiwan Cabinet approved the forward-looking development plan last year. There are 6 development programs: green energy, digital technology, water environment, railways, urban rural projects, and so on. The aim is to connect the digital technology with all the infrastructures. And our company is also bringing all the new technology in the past few years, such as big data, LiDAR and UAV survey data, and the application of BIM model, just I mentioned before. We try to combine our design with smart technology. Our goal is to design smart and also to do smart design. Hopefully, in the near future, all the roads in Taiwan will be smart roads and all the cities will be smart cities. This is the end of the presentation, and thank you for your time.